show you today how LangChain4j works, the Java framework to connect to large language models and some other AI models. Let me first present our team. So LangChain4j was created by Dmitry Liobarski. He's still the lead developer on the team, and we have by now probably over 90 contributors already. Individual contributors, but also people from Google, Microsoft, AWS, that make sure that we have all the latest model integrations in LangChain4j. So what does LangChain4j does? It's there on top in our DevOps cycle. We're going to build applications that use the whole machine learning and model part as API. We were inspired by the original LangChain that's made for Python because a lot of model development and machine learning and data engineering is happening in Python. It's very suitable for all this data manipulation. But when you start building applications on top, of course, Java is the better choice because it comes with all these security features and everything that we have built up over decades. So what does LangChain4j does? It allows you to connect to different LLMs very easily. So there's a lot of providers, there's a lot of models, and LangChain helps you connecting to this zoo in a very easy way. But it has more than that. You can chain your requests, so have multiple things happen one after the other. You can build agents that can actually do things and operate. They let you talk to your documents and more of those things. So we like that very much, and that's why we thought we needed to make this also for Java. Just to get all on the same page on terminology, this is mostly about large language models. So plain language model is the one that's going to either imitate or complete your sentence. These days, we're mainly using chat models that are trained to chat with you or to follow instructions. So that's all the ones we're going to show today are chat models. And then there's this different type of model, an embedding model. This turns your text input into a vector of numbers with different dimensions depending on the embedding model you've been using. And what it does is it encodes the meaning of the text you've sent in. We will see a couple of applications of that today. Typically, we'll store the vectors that come out of this in an embedding store. Why could you use these vectors? For example, to group things with a similar meaning. You can have clothing descriptions, for example. You will have all your vectors of the different clothing descriptions in your embedding store. And then if you encode the word red also, and find the most similar vectors there, these will probably clothes that have red in them. So that's how you use this. Some more things are the context window. When you use a large language model, you can send infinite characters in there. There's always a limitation, which is called the context window. It goes from a few pages to about 1 million characters in Google Gemini. The more you send in, the more you will pay. So when you really exploit this 1 million characters from Gemini, I think you pay about $3 per call. But usually you will just send in a little phrase and then it costs you almost nothing. Prompts are what we send in, so our question or a query is called a prompt. And tokens are kind of the characters that the model uses. So they are typically around 3 characters long. It depends a bit on the model. That's how they chunk your text up. Now, in LangChain4j, we have the following components. So we have the basic components, which are language models, of course, but we also support image models, and we hope to have sound models coming soon. We have prompt templates that make it easier to juggle around with all the strings. When you work with LLMs, you will be typically adding similar things around your original question every time, like be concise, or you're a professional developer explaining to somebody that already knows Java. Since it's going to always be used again, we have prompt templates to make that a bit cleaner and easier. We have output parsers. So models are capable of returning things in a certain output format, for example, JSON. And we take care of parsing this for you, so you can continue with Java objects, which is really nice and smooth. We have functionality to handle the memory, because models don't have memory by themselves. And then we have tools, so models can call other tools, all kinds of tools, I'll give you a demo of that too. On the right side, you see RAG. It's Retrieval Advanced Generation, and that's just a hard word to say interact with your documents or get information from your documents. We will look into more detail how that works later. And then we have a nice integration layer on top of all these basic components. That's AI services. We'll have a look what they do. They're really nice. You can also see on top there, those are some of the model providers that we have an integration with. So OpenAI, Gemini, HuggingFace, Ollama, there's so many. If you want to know what's currently supported, you can go to our GitHub repository, which is github.com/LangChain4j. There's our core code. And if you scroll down a bit in the README, you'll find documentation, if you need it, a getting started guide, code examples, in plain Java, in Quarkus, and in Spring Boot. We have a very nice integration with both Quarkus and Spring Boot. And then in the code examples, you find also the tutorials. A lot of what I will show today, you can also do by running through the tutorial. And oh no, they updated it. We used to have a very nice table with all our integrations, like till last week. Can I? Okay, well, on our well, yeah, we'll have to find it somewhere, right? No, let's scroll. Thank you very much. No, they updated it. Okay, I will complain. I will fix this. I hope by tonight you have again an integration table somewhere where you can actually find it. Good. Yeah, then I'll just say like that. So we have these known providers, Google, OpenAI, Anthropic, a lot of them. We also have things like HuggingFace. If ever you want to tweak a model yourself, HuggingFace has about every possible open source model out there for download. If you want, you can also run it, that they host it, and then you can easily connect to it right from LangChain4j. And they have also data sets and instructions how to fine-tune or train your own models, and you can also do it there. Very interesting. Another one you see here is Ollama. You can install it locally and then have models run locally, as I showed already during my keynote. When I connected to this Phi3 model, that was via Ollama. We also have an integration, so you can call it straight from LangChain4j. Okay, let me first show you a little full application so you know why you will be paying attention later. So you can pull the LangChain4j examples. So it's same GitHub, LangChain4j/LangChain4j-examples. That's still linked in the README. So the example I want to show you is a customer support agent that's written in Spring Boot. I'm not going to dive into the code, but I'm just going to run it and then explain what happens along the way. So it has no nice front end. We'll have to look here in my console. So what we get to see here is the user. And this is car rental service assistant. And I want to cancel my booking. So I ask, can I cancel my, oops. It would deal with my typos. Can I cancel my booking? So what's happening here behind the scenes is that it will find the parts of our terms of use that apply to this. The model is also told what its role is for which company it works, and it's going to see if it can help me. So what we get actually back is here. To assist you with canceling your booking, I need the booking number, your name, and your surname. Could you please provide me with this information? So why is it asking this? Because it knows it has a couple of tools available to cancel bookings, and those are the things it needs to know. So it's asked me for those and only those that it needs. So I'm going to write that is Lize Heisler, why not, and my code. So I didn't have to follow any formatting rules here. So what we get behind the scenes is a booking not found exception. this is on purpose, because I made a mistake. I am not Lize Heisler, so it couldn't find my booking. The nice thing is that what the user in the end gets back from the agent is that I couldn't find a booking with the provided information. Could you please double check the booking number, name, and surname? I'm going to say, oops, my first name is actually Klaus, of course. And now, I mean, it remembers what I said before, it puzzles it all together, and this time it finds my booking. So it has called a tool first to get my booking details, and then it gets them and it answers, I have found your booking details. Correct, and then since your booking period is less than 3 days, cancellations are not permitted. So it knows these booking dates from me, it knows we also told it what date we are currently, and it knows from our terms of use that it can't be cancelled if it's less than 3 days. Now, sometimes applications with LLMs in them are very non-deterministic. They will sometimes do a different thing. I'm going to try to cancel it anyway, because sometimes it tries, and it's supposed to get a booking cannot be cancelled exception. So actually, it listened to me, which I doubt is a good. But so it tried, and it gets this booking cannot be cancelled exception, and then, yeah. So again, per our cancellation policy, it cannot. So this was a little demo of how you can make a real functional chat agent with this. Now, let's take this from the basics. Let's make a hello JSpring example. Gonna pick that from here. And I will do some live coding because, yeah, I like challenges. So first thing, if you want to use LangChain4j, you have to import our core dependency, just LangChain4j. And I'm going to use for the demo OpenAI models, typically GPT 3.5, which is fast and cheap and relatively good, as long as you're not asking anything about coding. So then I'm also pulling this OpenAI dependency, but like if it was the Bedrock suite of AWS, you would just replace this by Bedrock, for example. So a hello world example here. That would be, we want to have a chat language model that we're going to call model, and we want an OpenAI chat model because we want to connect to their GPT models. The only thing I absolutely have to set on an AI model is an API key. And I've stored one, but actually we also, if you want to try this at home, we have a demo key for the OpenAI model. You can make a couple of calls with it. So let's see if that still works. Then we want to get an answer. We're going to use our model, and we're going to say model.generate, and we want to say hello JSpring. And then we're just going to print that. I want a compiler that also fixes all my typos. This will give us either a response or a string. Yes. Okay, let's see what it says. Hello JSpring, how are you doing today? Which is not what we asked it. And this is number one rules when you work with LLMs. They will not simply do what you ask them. So you have to keep that in mind. It's a whole different mindset to work with LLMs. And depending on what you want to get out of it, you have to be really specific in your prompt. OK, that was the hello world. Now we're going to dive directly in this AI service layer, because then it's really easy to add all the other components to it. So let's see what AI services are good for in our, let me see, too many repositories open. Yes. By the way, we also have in our tutorial image generation example, an example how to set all the parameters on the model, which you can really easily do, and examples of this prompt templates to handle the strings easily. That's you all find in the tutorial, but I don't have time to show it today. So let's jump to these AI services. It's a concept that is LangChain4j specific. It's a bit like the chains of LangChain, but not entirely. We find it more flexible and more adapted to Java. So again, I have a model here, and you can see here we set the timeout, for example, but you can set so much more, like temperature, logs, everything you want. That's how you set it. So we have, again, an OpenAI chat model. GPT 3.5 is the default. So in LangChain4j, everything works with same defaults unless you override them. So the most basic AI service that we can make works like this. It's an interface that we define, and we say this one has one method chat. It has a string input and a string output. That's it. LangChain4j will know, okay, one method, string in, string out. It's just going to send a call to the LLM. So we don't have to make an implementation of this interface. We can just create it by doing AI services.create with this assistant class that we just defined. And we have to specify the model it has to use to call. And then we can use this. So LangChain4j takes care of creating this object for us, and then we have our assistant, and we can call assistant.chat on, and here we define this text, which says translate plus-value de session machin. It's something of a French text form, and if I want to know what it means in English, then I can call this method. So if I run this, we should just get a translation. There we go, capital gains and ta-ta-ta. And it's not that I understand it much better now, but just to show you how this AI service works. Now, why would you do it this way? Because you can do much more. So the next thing I want to show you is take it a whole level up. This is also an AI interface, an AI service that I want to define as an interface. This time it has 3 methods in there: a translate method, a summarize method, and an extract date time from method. The extract date time from you've already seen in action before. Let me show you the other 2. We have this translate method, which takes in a text and a language. And then we can annotate the variables, so we can actually use them in system message and user message. System message is a general instruction that applies the whole conversation, and a user message is the actual question you ask. So system message, general, you are a professional translator into this language. And then the user message, what we really ask is translate the following text. And this will return us a string, should be the translated text. We also have a summarize method taking a text, a string in and an integer. And we're going to ask, summarize every message from the user into n bullet points. Provide only bullet points. Again, like, why did we put this here? Because otherwise it's going to write a lot of blah blah around it that we do not want, because we want to continue working with a list of string afterwards. So we're going to have as a return type a list of string and bullet points summary of this text. And the local date time you've already seen. It's a really easy one, extracted date time, and we want a local date time back. So 3 methods in our interface: translate, summarize, extract date time. And now we're gonna again do AI services.create. We build our text utils, and then we will use it. So we call it utils. Utils.translate hello, how are you into Italian. Then we will summarize this little text about AI here into 3 bullet points. So summarize the text into 3 bullet points. And local date time, it's just another text, this time 15 minutes shy of midnight. We're going to print our local date time object that rolls out of this. So when I run this now, we should get these 3 answers printed to console. Ciao, come stai is indeed Italian for hello, how are you? We have this 3 bullet point summary as a list of string that we can just continue using. And we have a local date time object here, which is usually correct. So that's where AI services come in super handy. And like the real programming behind this, it's not much. It is more prompting that we've been doing. Now it gets even cooler. We can also extract plain old Java objects. So yes, go ahead. No, yes, it will not be the same. The summary will be different. But the other 2, since they are pretty deterministic, will say 95% be correct. So so ciao, come stai? It's always the same because it's really a clear answer. That's right. So this is going to be slightly different probably, and this is going to be correct again. I must say, 1 out of 20 times it gives me 2 bullet points. just so you know, like you always have to stay aware of that. And we're working on a retryer inside where you can give a criterion if the answer passes. So if you have a list and you get a list back that is not n bullet points, you just relaunch it. And since 95% of the time it's correct, usually one relaunch and it's fixed already, and then the user doesn't even see the wrong answer at all. Yeah, okay. So when we move on to the Pojo example, I've defined here a recipe class. It has a title, a description, a list of string steps, and an integer preparation time in minutes. We have LangChain4j specific annotations here, the description. If it's not clear from the name of the field, then we can say short title, 3 words maximum, for example. And here for the steps, we did each step should be described in 6 to 8 words, and the steps should rhyme with each other, just because. And this is quite hard, so this doesn't always work. Good, so this is our object, and we have a toString method because we want to print it afterwards. Now, our AI interface is going to be quite easy, our AI service. It says create recipe from variable number of ingredients, and we want to return our recipe object. So let's see if it manages it. We create an instance of our AI service, and then we use it. And we want to create a recipe from this list, cucumber, tomato, feta, and such. Yeah, so guess what it's going to give? It's going to be a Greek salad. So I like to tweak this and say, I want frietsaus instead of feta. And the nice thing is, we did this to annoy a Greek colleague of ours. And when we put fondue in it last time, it really failed. So it still gives us a Greek salad. The drizzle with frietsaus. All right. So about the rhyming here. Chop veggies finely, mix in a bowl, drizzle with frietsaus, toss and roll. Squeeze lemon juice, season with salt, a flavorful salad, a taste of salt. It's amazing. Okay. I'm happy it listened to me. My Greek colleague is not going to be happy. Okay. Yeah, so that were these AI services. It just changes the whole concept of coding. Again, use the right tool for the right job. This is useful for specific use cases, of course not for doing all your code. Okay, let's move on. We will often want to chat with our AI models. So the examples you saw before, they're like content generator, one shot, and you get your answer. But very often we want to also build a chatbot. In that case, it's important to know that the models are stateless. So if you just would send in, I'm Lize, it's going to say, hello, Lize. If I'm going to say, who am I? If I didn't take care of a memory, it's not going to know. It's going to tell me it doesn't know who I am. So that's why we actually have to take care of managing this memory. And this is what it looks like. There's this one system message that's a general information for the entire conversation, such as you're explaining this to a 3-year-old. So that it knows when you ask, does Sinterklaas exist, or Sint-Nicolaas, I think you guys say, that it doesn't say no to my toddler. And then there's a first user message, and you give both, and you will get the first AI answer. So in LangChain4j, we call it user message, what I send in, AI message, what the LLM sends back. But then if I want to ask a second question, user message 2, I will also have to pass the first user message and the first AI message, and so on. So this is an example of actually asking question number 3, and you have to pass all that to your model, and it will give an informed answer. As a demo, I wanted to show you a little abuse, or no, first we're going to just use it properly. Let's be brave today. So we're building again an AI service assistant, again with a simple chat method, string in, string out. It's just going to go make a call to the LLM. But this time, we are going to add a chat memory, in this case, a message window chat memory with maximum 10 messages. Why are we cutting the memory? Because, as you remember, our context window is limited, and also we pay for every character or token that we send in. So We have a couple of default implementations for chat memory. We have one with a max number of characters. We have one with a maximum number of tokens. If you want to have a real clear control of the cost is always per token. But I'm also thinking of implementing a summarizing chat memory that instead of keeping all those messages, summarize everything that has been said before. So you can actually go longer and still don't have too many characters in there. So we have now a chat memory with maximum 10 messages that are stored, then the rest is thrown away. We make our model again, and then we're going to build our AI service, but this time instead of create, we have a builder, because we don't just want to have our assistant with the model, we also want to have the memory. So then with the builder, we can add the model, the memory, and there we go. We can use this chat method now, and it will have memory. So for the demo, I'm first saying, hello, my name is Gandalf. That's my user message. I call this chat method with it. I'm going to print to the console what its answer is. And then I'm going to ask it, what is my name? And so this should work now, because we've added a memory. So, hello, Gandalf. It's nice to meet you. How can I assist you today? And then the second time it says, your name is Gandalf. So memory is working. There is a nice way of abusing memory. That's called the few-shot approach. So sometimes if you want a specific format of the output, I'm disturbed. Yeah, if you want a specific format of your output, then instead of describing it, you can also give it examples. And that's a very powerful method that works very, very well. So I'm going to make a fake memory. I'm going to pretend as if I have already asked questions, and if I have already gotten certain replies in a certain format or what I want, give a couple of examples as if we had a conversation already, and then send my next question with that fake memory, and the model is going to behave just like I pretended it behaved before. So let me show you how that works here. This time we're using a token window chat memory, just so you can see. We're using a specific tokenizer for the specific model, because it's related. So 1,000 tokens maximum in our memory. Now, we have a system message that says that there are a customer assistant for a phone manufacturer. Just as a general tip here, if the topic is not about the phone's hardware or software, you politely refuse to answer. Just a little tip if you make chatbots, because if you don't put that in there and you say like, explain me linear algebra, it's going to start explaining you linear algebra, and people are going to abuse your chatbot like a free ChatGPT, basically. So here we say it to refuse if it's not related. Now, I'm going to populate my memory with examples. So let me see, yes. So here, I'm going to say chat memory add a first user message, so a question I pretend to ask. Says, I love the new update, the interface is very user-friendly, and blah, blah, blah. And then I say AI message. I'm going to add this AI message, this answer. And the answer is, action, forward the input to positive feedback storage, new line reply, thank you very much. Da, 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 da. So I add this to the memory as if the model has answered this to me. Now, I'm going to also add a negative example. So the next I add is that a user said, I'm facing frequent crashes. And then the AI is going to answer, open a new ticket with crash after update Android as a topic. And then a reply, we are so sorry. And then I just put one other positive, one other negative example in there. I'm not even sure if it's needed. Might already have figured it out from 2 examples. Also, the examples are generated by ChatGPT, because we are very lazy today. And then, so I've stuffed that 2 negative and 2 positive examples with the reply I want in that memory. So when I create again my assistant AI services, I'm going to add this chat memory that I've pre-populated. And the last thing I'm going to add is, or like going to ask is, how can your app be so slow? Please do something about it. And then we're going to print what it answers. So I have not given any literal instruction to follow any format. I've just pretended the model has been answering. OK, so this is not. OK, he doesn't want to answer because he's unable to provide. Yeah, so OK. He took this a bit too literal here. Yeah, so here you would need to tweak your prompt to actually refuse in the correct instances. I'm just dropping the system message now. It doesn't know anymore. It's a phone assistant. It only has the examples now. And there we go. So I complained that it was too slow, and it says action, open a new ticket, app performance issue, and reply, we apologize for the inconvenience. So that's exactly the format I had given it. Without having to explain it, I can just give it an example, and it works really, really well. All right, so that was memory abuse. Good. Next level are tools. LLMs are able to call tools that you give them. So you specify which tools they have available, which input arguments they take, which outputs they give, and the LLM will be able to make a call that LangChain4j will parse then for you. They will make the call to your Java methods, send the answer back to the LLM, who will give then an informed answer that takes into account the output of these tools. Or sometimes the tools are also not giving a result, but they are like cancel booking. This would just be a call, and it would be like, okay, your booking is canceled now. So yeah, why we have this burning house here? Because you have to pay a bit attention what you allow users to do, right? So cancel bookings, you want to be sure that this user is allowed to cancel only its own booking. So yeah, watch out when you give it access to your database and stuff. Okay, let me show you an example of tools. It's a bit of a silly example, because I think the LLM might be able to figure it out without the tools. Why don't we ask it without the tools once? So again, we have just a simple chat assistant AI service. We have given it the memory and a model, and I have added no tools for now. And we're going to ask, what's the square root of the sum of the numbers of the letters in the words hello and world? And I think it might manage by itself. So it has no tools here. Yeah, exactly. It actually knows how to do it. But okay, of course we can give it more complex tools for things that it couldn't figure out by itself. So let me show how it works to define these tools. At first we want to have a class, calculator in this case, that has a number of methods in there that we annotate as tool. So these are really simple tools, but it can really call any type of Java method. So we have a string length method, taking a string in, getting int out. We have a sum, an add method that just calculates the sum of two integers, and a square root method that will give a double back from an integer. And you see I'm printing in every time I'm printing to the console what it's doing, just to show you that this code has really been called. And what we have here is this tool annotation that's important. So if we want to use them as tools, we need this annotation with an optional description what they're doing. I must say these are all here pretty self-explanatory, but sometimes it comes in handy. The model gets all this information, and then it knows which tool to call under which conditions. So this time, I've again have this AI service. I added the model. This time I add these tools from my calculator class, and again a memory. And now, if we run it, we should see that it calls our methods. Yeah, so string length, it called it twice, once with hello, one with world, then it did 5 plus 5, great. And then it called the square root of 10 to come. At least this time we know it's not going to hallucinate. Because that was, in the first case, that was totally possible. It would just pretend something. This case, it has really used our Java tooling. I would like to show you what it looks like behind the scenes. So let me put on the model log requests. And maybe also log the responses. And then I still have to make sure that my log is on debug. Oops. On debug level. So if I run this again now, we should see the logs. I mean, they're not pretty at all, but then you see what's actually, how these calls are made and how these tools are called. Okay, let's dive into this. Okay. So first thing we do is we make a call to OpenAI chat completions. We want the model GPT 3.5 Turbo, so that's our default setting. I don't think I actively set that. And then the user role asks, this is the question. This is the text. And then you see all the parameters here. And then you see also, we also send right away that there are tools available. So the OpenAI models support this tool concept. Not all models do, but most of them do. That you can find in that very nice summary of what we support that we cannot find at the moment. But so most of them support these tools. And then they say it's a function. It's called square root. It calculates the square root of the number. That was the description we said. And it takes one argument of type integer. And then we have this calculate. And so that's how the model knows it's there. Next thing that the model will do is it will call the function. So it's calling string length with the argument hello. And we have this call ID, which is how we then know how to return it. So we will return the answer with this ID, and the model will know, OK, this is the answer to this function call, and so on and so on. And so it's calling all these things one after the other by itself in basically one big call from our side. It starts doing this back and forth. And then when it has all the answers, it will formulate its answer, and that will be just another, here we go. This is how the real answer in the end looks like. The role is the assistant, which is OpenAI's version of AI message. We call it AI message, and then says, this is the real answer we get. That's how these tools work behind the scenes, but we made it really convenient with LangChain4j for you to use them. Yes? Yeah, it's a good question. So the question is, if you give the tools, will they, by definition, be called? So no, it can pick the tool it needs. But what we have seen is that this time it was picking out tools, the right tools, but for something it actually can do itself. So that's a nice thing. If you want to make sure it behaves well, then give it the tools, even if you think it could do it, because sometimes it will fail. But if for example, what you saw on the chatbot of the car rental assistant before, it was only calling get booking when it really needed, when it already had our name, of course, and our booking number, and then it was only calling cancel when I said it, like now cancel it. So yeah, it's pretty smart, I must say. It's pretty impressive what it does with this. Okay, let's move on to retrieval augmented generation. That is meant for all the cases where the standard training data of the model is not sufficient to answer your questions. So the models have been trained usually until up about 1 year ago. So anything more recent, they usually don't know about. And then they, of course, also don't know about anything that's specific to your company that is not a general online resource, well-known thing. For example, the terms of use of our car rental assistant. We want the model to be aware of these documents. So in a standard use of large language models, you have a question, and the large language alone will try to answer it, and this will be an uninformed answer if there was anything else you actually wanted it to know about. So how we fix this is that we want to also find relevant parts of our documents when we ask a question, and we pass our question together with these parts to our model, and then it will give an informed answer. So it's really nice because it hallucinates way, way less, if even not at all anymore. Now, why are we not sending our entire documents in this context window? Again, because it has a limited size. If you have plenty of documents, a whole repository, it will possibly not fit, and it will be expensive. So we are after only the relevant segments. That's what we want to find. Now, how do we find these? So then this is where the RAG comes into play. In the first phase, we will put all our documents through splitters that are going to split them into segments. Then we're going to run the embedding model on every segment. So we are going to obtain a vector that encodes the meaning of every part of text. And those vectors, those embeddings, together with the segments, we will store in an embedding store. An embedding store is type of database that's specifically optimized to very easily find vectors that are close. That's the first phase. It's in a different cycle of your program than when the user actually asks the question. So this happens before. You pre-populate that embedding store. And then comes the retrieval phase, where the user does ask his question. And you're going to embed the question as well. You're going to calculate the meaning of this question. You're going to look in the embedding store, which of my document segments are similar to the question. And only those you pick out and you send along to the large language model. That is what we call naive RAG. For some things it works well, for others it works absolutely not so well. But I still would like to demo you the naive RAG. I have made an example that I'm very proud of because, wait, didn't open it. Yes. What I have done is I have put all the LangChain4j documentation here somewhere in my resources because I want to ask questions about LangChain4j. And the model definitely doesn't know about LangChain4j yet because it's 1 year old. So this is what it looks like in code. We define an embedding model. All these model providers typically also have embedding models. So they're not their usual large language models. They are going to just translate text into meaning vectors, into numbers, and they work much faster and they're much cheaper. But we also have one that can just run in memory. That's very nice. It's not big and it comes as a dependency in LangChain4j. For proof of concept, definitely this is a nice one to use. For our embedding store, we're going to just for proof of concept use an in-memory embedding store. But again, LangChain4j has integrations with Milvus, Elasticsearch, Qdrant, like whatever you want really. We have plenty of embedding stores that you can just load as a dependency and use. Good, so we have a store to store it. We have an embedding model to calculate our vectors. And then we're going to build an ingester with this model, with this embedding store. And we need a document splitter that's going to define how our documents have to be split. Again, we have a couple of implementations. If you want another one, if you want something special here, you can implement your own version. And then if you think it's of general use, please make us a pull request, because other people may also be able to use it then. So this one is just recursive, saying you split it per 300 characters. Just chunk, 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 and you're going to have 30 characters overlap in case you have split in the middle of a word. So this is, as you can already feel, not the smartest way to split my document. It's super basic, but we also have a paragraph splitter, for example. So that's how it's going to chunk up my whole, all my files. So I have written a little method where it runs through this resources directory and going to chunk that all up, embed it, and save it in the embedding store. So this would be typically this ingestion lifecycle that happens once. Now I have it for demo purposes, all in one big program. You will see it ingest, and it's really fast. Now then, we're going to retrieve our parts when we ask the user question. So to be able to retrieve, we built this embedding store content retriever with the same embedding store that's populated now, with the same embedding model. That's very important because they're not compatible. All these vectors of different providers, they can have different dimensions. So same embedding model. And then I can say I want maximum 3 results with this minimum score. Now this is something you have to tweak depending on your documents. Like maybe you are retrieving Excel entries instead of pieces of text, and you know you almost always want at least 10 of them. So it's really depending on your data a lot. And also, so you know, document loaders, we have also plenty of out-of-the-box integrations, Word, PDF, Excel, HTML, URL, even GitHub, so you can just embed the whole repositories super easily. Okay, now we add a memory, we add a model. So this time the model is our real LLM that's going to answer the question. We'll get the original question in all the chunks and give a clean answer out of that. And then we're building a coder agent. It's, again, a simple AI service with one method, string in, string out, but we have a system message that it is a coding assistant to help with LangChain4j, basically. Voila, we add that all, so our memory, our model, and our content retriever this time, we add it to our AI service, and we're good to go. So I have a little console interaction written here. So this time, we're going to have an AI service with console interaction that knows about this documentation. So now you see it ingest. So that's super fast. That's all our markdown files from the documentation. What are we going to ask it? Generate, yeah, typos are fine. Generate a hello world program with Mistral AI instead of OpenAI that I've been using so far. Okay, let's click this link. Wow, actually it's not bad. It's maybe even better than when it would make up something itself, right? I don't dislike this. Okay, but give me the real code here. Now, let's see. Okay, that looks super bad. That's definitely no LangChain4j syntax at all. Okay, let's see. What dependency do I have to include to connect to Mistral AI? This it should be able to do. So yes, that's our normal core dependency, but it's not the Mistral AI one. Okay, it's really bad today. Good. So, okay. Well, pity. Sometimes it does it well, but this is naive RAG, and it comes with a lot of problems. The main one here, I think, is that I have asked a follow-up question. Okay, but give me the real code here, and it did a semantic search on that, like on things like real code give. It's definitely not going to have found our Mistral AI examples at all. So that's one of these disadvantages of naive RAG, and that's why I will show you that there's advanced RAG later. Now, I'm just really curious to try this again. Maybe it just wanted to punish me for my typo. Hey. No, yeah. I mean, at least the link works, which is already nice. Good. Failed demo. How to not do it. Good. Right. So that was naive RAG. Yes. Yeah, and since I have an old copy of the documentation, it might still be in there. Which models and model providers, LangChain4j. Okay, it's a stupid, wrong question. Integrate with it makes no sense, but I hope it gets me nonetheless. Okay, OpenAI, HuggingFace, Google, Azure, local model wrappers like LangChain4j. That is all correct. Nice, and it even tells me where to find. Should we try this? But I'm afraid it's gone. So how do we get there? We were here, right? Intro, and what did it tell me? Oh, sorry. It told me category integrations. Let's see if I can. Yeah. Nice. Wait, let's go there. Language models. Yeah, I mean, it's sort of. It's not the table I was hoping for, but it's indeed all our integrations. No, it's their comparison table. Thank you. Amazing. So now you guys all know where to find it. You just build a RAG system on our documentation, and then you'll find it. Okay, amazing. So actually, here you see which models providers we integrate with. Which ones have the streaming version, where you get the answer like token by token, which is sometimes interesting for chatbots. So now I've been just showing it in sync version every time. The ones that support tools, the ones that work with images, the ones that are local, and the ones that have native builds as well. So native images is also supported for a couple of them, and it's really nice. Oh, well, thanks. It was a joint effort to get there. Good. We've already seen a bit of these limitations of this naive RAG. So we also have an advanced RAG. So instead of going from user message to content in the normal way that we just saw, we can use this whole schema. So what we have in there, like below you see which implementations we have out of the box. All the gray parts are interfaces, so you can make your own implementation if you don't like it. And again, if you think it's of general use, please make us a pull request, and then everybody can use it later. Let me tell you which components we have there. So the first one is a query transformer. As you already saw, I asked a follow-up question about Mistral AI, but it didn't mention Mistral AI, so it's never going to find the parts about Mistral AI. So a compressing query transformer will just make sure the whole content from what has been said before is in your line when it's going to find the relevant pieces. So in my case, I asked which dependency, or I don't know, some follow-up question. It would probably turn it into dependencies in LangChain4j for Mistral AI, for example, and then it will actually find the parts that it should find. Expanding query transformer will turn your question into multiple questions that could all yield good results, and then you get more segments. So you're sure it's somewhere in there. The query router, I've already talked about this shortly before, in my talk before, where the LLM can decide where it should retrieve the content from. So embedding store content retriever is the one we saw before. Go look in our embedding store for something semantically similar. But you can also have a web search engine content retriever, SQL content retriever for a normal database, or a Neo4j content retriever for a graph database. And the model can take care of routing it, unless you can also have something rule-based that you can implement yourself too. And then it will also make the right queries and call these retrievers. The content aggregator is where we put all the chunks together. So typically the default one looks like question. You can use these fragments, and then come the fragments. But we also have a re-ranking content aggregator that's going to kick out all the results that are not relevant. So you define a relevancy threshold, and you only keep what's really relevant. So that's another little model that comes in to actually recheck, which is very important, because often with RAG you find parts of the documentation that are not relevant at all. And then this re-ranker will kick them out, because if they stay in, your model is going to try to use them in the answer, even if it has nothing to do with it, and it's really disturbing, actually. And then content injector just means you put your original question back with it. Yeah, let me show you one within a framework, within a Spring Boot one. No, within a Quarkus framework. I've already showed the Spring Boot example at the beginning, so now I want to demo some other tool that is making use of advanced RAG. And it's this feedback analyzer that hopefully will run this time. So while it gets up, I show you, it's open source, this one, so you can find it on my GitHub, feedback analyzer. Ignore the tree, I should get that off. There's LLMs involved in multiple steps here. So first thing is we collect user feedback. Maybe you remember it from before. And the user can just dump all his feedback in this one text box. Like, can be really mixed topics. It's thought to be a coding lab feedback analyzer, but you can, of course, tweak it to analyze whatever type of feedback. First thing we're going to do with AI is to split this big chunk of user feedback in pieces that hang together, that are in a similar category. And then we're going to have it analyze each of these chunks and to say how urgent are they, what category are they in, are they positive, are they negative, things like that. So let me already show you that. I guess it's up by now. Yeah, there we go. So let's just enter something here. I'm from Belgium. And say the examples were really inspiring, but the food tasted terribly bad. like cardboard. OK, I'm making this a bit recognizable because we want to find it back later. So when I submit this, it's going to get split, hopefully in 2 pieces, because one is about examples. It corrected my typo. Great. So yes, one is about the examples, and the other one is about the food. And then it tagged one as in the category examples, one in the category catering. So it's an enum that I gave it. Yeah, and then it gives some severity and urgency score and impact scope, which you could maybe use for something else. Then there's another aspect to it here, where I have a dashboard on, there's some example feedback in here, and we should find my new ones are in here too. And it has then a chatbot where you can analyze it with, and that's very interesting because I'm going to ask it, what did the women find about the food? Now, while it thinks, no, enter doesn't work here. While it thinks, I'm going to show you this. These atomic feedback parts that were had their analysis values to it, they're stored in a normal SQLite database that gives the info to the dashboard for the graphs, but they're also embedded. Go in an embedding store for doing semantic search on there, but there's also a metadata filter. So I've only embedded the real text. So the real text was something like the food tastes like cardboard. It doesn't say if I'm a woman or not in that part of text. So the metadata filtering, I have added metadata to my embedding store saying I'm a woman, that's my age, that's my nationality. And I've added the metadata filtering option from advanced RAG, so it should find, based on the feedback, the women found that the food tasted like cardboard. So that's very good. Now this gets interesting when there's a lot of feedback, right? And you can, yeah, you will get it all grouped and very informative. I'll just quickly show you in the code what this metadata filter looks like. So you can go check out that code. I've done a real effort to make it all very clear where everything is. So AI services are here, endpoints, the chat socket is here. And I give it a definition that there's gender, birth year, nationality, and severity as metadata annotated. And then I have a language model SQL filter builder that takes this table definition. And then I'm going to add that to my content retriever. I'm going to say there's also a filter you can use. And then again, I add my content retriever to AI services. And that's how this is one of the aspects of advanced RAG. In our examples, you have a whole folder called RAG examples. Wait. That shows you all the, so easy RAG, naive RAG is one we saw. And then in advanced RAG, you have examples of, oh, there's more than usual, that's nice. So you will find query compression and everything there if you want to use it yourself. Okay, and then we're almost through. Yeah, so if you want to make a pull request, be our guest. I don't think I have time anymore. No, sorry, so we skip this. Thank you for your attention.